Windplanner can run simulations to gain insight into shadow flicker and sonic impact of turbines. In this video, I will show you how to set up both simulation types and create your personalized data report. Let's start with the shadow flicker simulation. Navigate to Edit, Turbines, and then Simulations. Under Create Simulation, fill in a name and select a simulation type. As I mentioned, you can choose from shadow flicker or noise. Next, we can specify the simulation contours, personalizing the way that the generated data is presented. The difference between choosing number of contours or contour levels is that with number of contours, you define the number of contours to be calculated evenly spaced between 5 and 300 hours, while with contour levels, you specify the exact values of the levels you want to be calculated. For example, 0, 4.5, and 10 hours. Then we have sunshine probability. Here we can fill out the percentage of time the weather is estimated to be sunny during the day. As it says, it's not needed to take nighttime into account, as this has already been taken into account by the calculator. Of course, turbines aren't operative at all times during the year, which may be due to maintenance or a lack or excess of wind. All of this can be factored into the computation by filling out the percentage of time that the placed wind park is serviceable. Finally, we can place data receptors to locally receive a detailed data report from specific locations of particular interest. Be sure to have the right layout selected that contains your wind park, and click on Create Simulation. You can check your simulation status in the simulation list. Once the simulation is completed and you click on the gear icon, you can reveal your simulation result by clicking on Show Report. The report consists of an organized document in which the information is arranged that Windplanner has generated. It contains visual representations of the data, and of course, from here it's possible to find the information relevant to the specific receptors we just placed. At the end of this document, you can download this as a PDF by clicking on the bottom right button. Furthermore, under Create Result layer, you can visualize the results on the 2D map in Windplanner. It has created a new custom layer that you can disable or re-enable as you would expect from any other layer. What's more, you can download the results as a KML file to use in your GIS application. Now, setting up a noise simulation is a lot like setting it up for the shadow flicker we just discussed. Nevertheless, let me walk you through it for good measure. Fill out a name as we did previously, and select the noise simulation type through the drop-down. For the noise model, you can choose from the standard Dutch calculation method or the ISO 9613 model. For the noise simulation, we can choose from contour numbers, contour levels, or contour spacing, with each type being further customizable and defined in level day evening night, or A-weighted decibels. Next, it's time to factor in the effect of the ground on the noise, at the source, in the middle, and at the receiver. 0 means hard and thus reflective. 1 means porous and thus non-reflective. However, you can also select from ground presets, like compact ground or gravel, grass, or concrete. Finally, we can customize the receiver height. The next step is to specify the sound spectrum levels of the turbine, per frequency. When you've done that, you can place the receptors like we did with the previous simulation, and make sure to select the layout containing your wind park. Now let's let it run. Once more, we can reveal the results and inspect a visual representation of the data. we can examine the specific sound levels measured at the receivers. and we can download these results as a PDF. Again, as you would expect, we could visualize these results in Windplanner or download the KML file.